Alright, hi guys, Jiggy here, a little tutorial on how to generally find things and edit them in MSC, some of the tricks to get things working your way. Firstly, you're going to have to find PyMSC, which is on github.com/jam1garnet/PyMSC, and you can download it via zip, or you can clone it with git clone in your environment. Just get it any way you want. You're going to need Python 3, obviously. A lot of this tutorial is going to be under the assumption that you've read at least most of the MSC tutorial, which was written by Jam. It's super helpful and it'll tell you how things work. So if you really want to understand how everything is processed in ASM, you'll want to read these. Generally, for just replacing things, you might not need to know everything, but yeah, it'll be super helpful. All right, anyway, so I have downloaded the entire repo here, and sorry, I'm used to bash, not the command line. But anyway, so we're in this directory, and we have here asm.py, disassembly.py, the mu, which is good for learning, and then msc.py, which is for generally just it's just the library, and so on. Everything else doesn't really matter that much. So what you're going to want to do is use Python disassembly.py, and it takes an argument of any MSCSB file, which can be found from your Smash Explorer extract. So to get there, you can just go extract data fighter, and I'm going to be using peaches script. No. MSC peach.mscsb. So it will disassemble the MSCSB and it'll put it into a directory called output in the same directory. These are all quote-unquote missed offsets, but you don't have to worry about them. It's not actually missing any offsets, unless it's like Mega Man or some edge case. But okay, so now that it's done, you'll see there is something called output here, and I'm going to open in a text editor just to show you. So if I go into PyMSC master output, there's like thousands of scripts here, like usually 2,000 something for most characters. Kirby has like 4,000 something for some reason, probably for his copy abilities. You can find out what globals.txt does and the full scripts file in the wiki, but we don't really have to worry about that. So basically what I'm going to try to teach you is how to find things. I think there are 3 main ways to find things. There are probably more. The first one I'm going to go with is animations. So I'm going to try to replace the entry animations with the final smash animations. So generally what you're going to need to know is this simple trick given a fighter.mlist, which it'll come whenever you decompile any fighter with fitx or fitd to be precise. So you'll have this in the folder, and it'll tell you the animation ID. I do believe in Smash command it also has the animation IDs. But anyway, so we're going to want to find out where the entry animations are played, because they're really just animations, and in MSC they're going to be as simple as that. So we're going to look for entry, and we're going to find that they're on line 422 and 423. So essentially these line numbers are approximately the animation IDs, but since the animation IDs are 0 indexed, we're going to have to, and this is 1 indexed, we have to subtract 1. So the animation ID for entry R is going to be 422 minus 1, 421, and the animation ID for entry L is going to be 422. And finally, we're going to need to convert that into hex, because that's what MSC uses for the most part. So we're going to need, you can just use your default Windows calculator. It has a programmer mode. So 422 is 1A6, and entry R was 421, so that's 1A5. So we're going to want to find, you need to somehow find a way to search through all the files in this directory. There's tons of different ways. If you're using bash, you can use grep. I'm going to be using command line because it's very familiar for most people. So I'm going to be using find string. You can use even this atom editor. It parses through full directories. Yeah, most text editors have something like this. And so I'm going to look for 0x1a5. Note that I'm doing lowercase because that's the default output. I'm going to put this, meaning that's the last thing before the end of the line. I'm going to look through all the files in this folder. So quickly it found that the only two references to that are in 2158. So we're going to look into the output folder and find script 2158. And generally, like, note that it's not always this easy. Sometimes you'll get a ton of false positives, and it could just be pushing the number that you're looking for, because this is just a number as well. But in this case, if we look through this, a lot of this is just a bunch of checks. We don't really need to worry about that. More checks, more checks. And here, basically, what you need to do is you should always have this MSC sheet open, because what we're looking for right now is where an animation is called. And and if you want to find this MSC sheet, it's in the Discord. I'll post a link in the description and so on. But this is a very important set of instructions. So you push, when you see push int, this is the animation ID. This is something we're not too sure of yet. This is the animation speed, like multiplier, and script 22. Script 22 just means that's where animation calls are handled, and call function 3, which again, you can look in the wiki to find out what that means specifically. But so we're gonna want to find push int 0x1a5 or 1a6 as we find here. So this is entry L, and notice that it's in a try block. So this tries and it calls animation 0x1a6, which is entry L.acm. So, but we don't actually want this to happen. Since I want to replace this with the final smash animation, I'm going to look through here and find out what the final smash animation ID is, which is 595. So we do 595 minus 1, which will give us 594, and the hex for that is 252. So we'll replace this 1a6 with 252. So now instead of entry L, which is when you enter on the left side of the screen, it'll play the final smash animation. That's not good enough because we want to do it for both sides. So down here we can see that it happens again, or like right next to it. So this will call animation 0x1a5, entry r.acm, and we'll again change this to 0x252. So basically that's the entirety of that. Whenever you see this set of instructions, this is always calling an animation. There's a different type in that is script 23 that passes the current frame of the current animation into that one, but usually that's not too often found. So that's generally how you do animations. Next, what I think is probably more powerful than just controlling animations is the way that parameters are stored in MSC. They are all referenced in a certain way. We only know about some files. For example, we know fighter param common, we know fighter param for each character, and we even have some for fighter param VL. But perhaps the most important are fighter param common ones. They're referenced like this. Whenever you see a push int 0x12 followed by 6 characters, or 0x2 followed by 6 characters, those are going to be parameters in fighter param common, and the same for 13 and 3. This means that it's a basic value, which means an integer, and this means that it's a float value, which is like a decimal. So looking at this other sheet that holds fighter param common values, if you can just look through SmashForge's ionize or whatever you want to do to find this if you don't want to look at this sheet. But yeah, basically you can see that the name value is what is used to be the identifier. So say, for example, we have ID 115. Since 115 in hex is 73, it'll just be 1, 2, 4 zeros, and then a 73. It really is that simple. All right, so given that we have this information about parameters, the next thing that I want to do is there is a parameter right here that is 327. It says frames in between respawning and taking control. And even in the notes, it says lower number equals respawn platform descends faster. This is 60 in hex. So what I'm going to do is I'm going to find out where that happens, and then it'll give us a lot of information. So we're looking for 327. That's 147. So we'll look for 0x 123 147. And then we find it's only referenced in 2 places, in 234 and in 1662. I've already looked at this and found that it's most important in 234, so we'll go there. So here we're looking through, and then we'll find out where that's pushed. So generally getting variables looks like in complex CMDs or variable operations. Get variable can either be accessed, push in 0x6, and then this is the variable ID right here, and then you have a 6 call 16 in hex, and that'll just get the value and push it onto the stack of that variable. And the same thing happens with 17, with the first argument being 0. You can also set them with 7 as the first argument and calling 0x16 in this fashion with the ID being here, and what you want to set it to as the second argument, and so on and so forth. You can read here. Anyways, so these 3 lines mean get fighter param common sub 327. All right, so if I want to change that for some reason, I think what I'm going to do is increase it by a factor of 3, so it'll take like 3 times as long to move after you've respawned. So if that pushes that to the stack, and then it sets it into this variable, what instead we can do is I can push in 0x3 and do a multi. So this will essentially take, this pushes 0x3, and then this will multiply the 2 values on the top of the stack, which is going to be 0x3 times a fighter param common 327. So instead of pushing 60 into this variable and then processing it however, it will push 60 times 3, 180. So it'll take 3 full seconds to act after this. And then, but generally, if you can see the real power of looking through parameters and animations so far, because now we can find that this is like one of the main respawning scripts, the other one being 1662. So you can see there are even other parameters that are referenced here, or actually this is a bit variable. There's also a bit variable. But so you can see this is where like all the parameters would be referenced if respawning was more complicated. These bit variables are like checked, and so on and so forth. Next, I'm going to talk about probably the most powerful thing, and that is actions. Actions that are way more powerful than animations. Here we can see if you want to change action, you just put the action ID and then call script 16 instead of script 22. There's no speed or anything. And the best way to look for actions is, it's actually more difficult. The best way is just to look through the list that's already been compiled. I've added only a few of these. Most of these are done by Stinny. He's a legend. Anyways, so if we want to find... So the next thing I'm going to try to do is something that's way more powerful because it's controlled by actions. I'm going to try to force anybody who's on the ledge to do, say, a ledge roll. Okay? So in order to do that, I can find where this happens by just searching for one of the action IDs. Obviously, this is a lot harder because these look more like normal numbers, but we can try anyways. You can even... So this gives us a lot of different things, and you can use this in conjunction with knowing what the animation is for ledge options and so on, and you can narrow it down that way. Fortunately, I've already done the work because I've looked at the ledge scripts before and edited them. So I know that it's in script 166, which is found here, as you can see. So generally what this script does is it does a bunch of these checks. This is a if grounded check. You'll just do a wait, which is 0x0 action. If you're aerial, you'll start falling, which is 0xe. And then if some other variable is not set or blah, 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 it's doing some checks, blah, 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 and damage fall. And then from here on, it starts calling, for example, 0x78, which is cliff jump, which is just doing a ledge jump. And then what's cool is it even does some input detection, and then it'll call 75, which is ledge attack, and so on. Once you get better at reading this, you'll be able to see this is just like the ledge script, like what do you do when you're on the ledge. But what I'm going to do is something very simple. I'm going to just force it to ledge roll every time you're on the ledge, no matter what. So whenever you're calling something, an animation or a change of action, you have to embed it in a try block. So we're going to do try ledge roll, and then we're going to do push int 0x, and it was 77, right? Yeah, 77, push int, again, I don't know what the 0x0 exactly means, push int script 16, and then call func 0x2. And just this is the way that try blocks work. It'll just go to this after it's done, or if it failed to change action or something like that. So generally, all we did was, this is the start of the ledge script, and instead of doing any of the checks, which is kind of dangerous in some places to do, but we're just doing no checks, and we're going to force it to ledge roll. So to go over what we've done, I've changed the entry animations to the final smash animations, which is a little jank. I've changed the respawn timer to be 3 times as much as it was before, and we've forced a ledge roll every time you're on the ledge. So now in order to just assemble this, since everything has been changed in the output folder, you want to do Python, and since ASM is going to be in the previous folder, we just do a little relative path kind of thing, asm.py, and very quickly oh wait, I messed up. One thing you need to note is that when you're doing a try block, you don't put a colon there, or an if or anything like that. Don't put a colon there. Only put it when you're actually referencing the real, where the location is. And now in that folder, we'll see that, let me just navigate to the folder. We'll find that the output is a file called test.mscsb, and you're going to need to rename this to whatever character you're going to put it over, obviously, or whatever weapon or whatever MSCSB it governs. And now I can put that MSCSB in here and simply build it. Yeah, generally you're only going to be modifying the main character's MSCSB, but for example, like Bayonetta has MSCSB for her bats, and some people have it for their weapons. Even though Peach has some weapons, she doesn't actually have MSC for them because they're not that complicated. Okay, so now that we built it, I can try to show you what it looks like. I just have some scripts to move the output of the built mod into CEMU, and we can start it. It's probably going to be really laggy because I'm recording. As you can see, the camera gets super messed up because there's 2 people doing Final Smashes at once, and but it generally did what we wanted it to. And since I guess it wasn't called correctly with the camera, it doesn't actually go back to normal. But you know, if you use the correct animations in the right place, it's gonna work as you want it to. For the next ones, I'm gonna test in training because there's no entry animations there to screw us up. Okay, so the other 2 things I changed were when you are on ledge, you're forced do a ledge roll. So I'll first show that. When you have a CPU set to stop, they always do ledge jump. So if it does a ledge roll, then we're going to know that we've done it correctly. And it does a ledge roll. Perfect. I'm going to keep doing ledge rolls. Yep, that's another ledge roll. Okay, so there's that. And then for the next one, I'm going to use a different character from Peach because I didn't apply the MSCs to any other character. So we can compare the platform respawn time. Okay, so I'll set him to control so he just dies. So now we both died at the same time. I'm spamming down, and even you can see that the respawn platform takes 3 times longer just to come down. So that actually worked exactly as we planned. We just multiplied by 3 and it worked. And if you remember in the notes, it said that even the platform would come down slower than it would usually. So yeah, that's the tutorial. Hopefully I didn't miss too much. I know I did because this is actually a very large scale, very powerful tool. But hopefully you learned something, and I'll catch you guys later.